ellipse and the point in the plane of the ellipse. So we are going to discuss about the about a particular point. So regarding with that particular ellipse in that plane, suppose if you are having a plane, that plane you are having a ellipse and a point, right? So we are going to find out whether the point is inside the ellipse or outside the ellipse or on the ellipse. That's all, right? So for that we are going to discuss that one. Consider the ellipse x square by a square plus y square by b square equal to 1, where a greater than b. So we are taking a greater than b, so b greater than a is also there. So whatever it is, the same results will applicable for that also. That is why we are proving all the results with the particular ellipse x square by a square plus y square by b square equal to 1, right, where a greater than b, right? Now consider the ellipse, right? So this is the ellipse. Let p x1 y1 be any point on the plane. So this is the plane, right, such that we are choosing that point is lies between minus a to plus c. Then only it will come inside, right, inside the major axis, right, a dash, within that limit. Otherwise it will go outside that. That is why, that is mod x1 is less than a. So we are choosing like this. See p x1 y1. So 0 to a, right, this center c to the vertex a. The distance is small a, right? So p x1 y1 in between, the x distance is in between a. That is why we are choosing that point like that, right? So draw Pn perpendicular to the major axis a dash, and Pn meets the ellipse 1 at Q. So draw a line Pn perpendicular to a dash, and Pn meets the ellipse at Q. Now Cn, that is the x distance of P, that is x1, and Pn, that is the y distance of P, that is y1. And the coordinate of n are, so n coordinate, this is on the x-axis, so that x distance is x1, then there is no y distance, right, because it is on the x-axis, so x1 comma 0. The coordinate of q are q, that is q is on the ellipse, so Cn is the x distance of q, and nq is the y distance of q, right? So q, so Cn we know, that is x1, right? So q is q1 x1 comma nq. Now nq, let it be y2, so coordinate of q is x1 comma y2, right? Since x1 comma y2 lies on the ellipse 1, so the points x1 and y2 satisfy the equation. So put x is equal to x1 and y is equal to y2 in 1. So x1 square by a square plus y2 square by b square equal to 1. So y2 square by b square is equal to 1 minus x1 square by a square. Therefore y2 square is equal to b square into 1 minus x1 square by a square. So that is equal to b square into, taking LCM, a square minus x1 square by b square. So y2 is equal to plus or minus b by a into root of a square minus x1 square, right? So hence the coordinate of q are, suppose q is on that side, q x1 comma b by a positive side. Suppose if it on the negative side, it will take minus that y coordinate, right? Y coordinate is either positive or it can be negative. x1 comma b by a root of a square minus x1 square, or q is x1 comma minus b by a root of a square minus x1 square. Now consider Pn square, right? Pn square minus Qn square by b square, right? So y1 square minus b square by a square, substituting the values, right? A square minus x1 square by b square, right? So that is equal to qn is y2, that is why we are taking that value, right? Qn value is b by a root of a square minus x1 square by b square. So y1 square by b square minus divided by b square minus b square by b square plus x1 square into b square by a square b square. So x1 square by a square plus y1 square by b square by b square 1, that is minus 1, right? So case 1, suppose p x1 y1 lies outside the ellipse. It is outside the ellipse. Then the distance pn square is greater than qn square, because p is outside, q is on the ellipse. So the distance pn is greater than qn, therefore pn square greater than qn square. So pn square minus qn square greater than 0. So pn square minus qn square by b square greater than 0. If and only if x1 square by a square plus y1 square by b square minus 1 greater than 0. So the value, suppose the ellipse equation is x square by a square plus y square by b square equal to 1. That implies x square by a square plus y square by b square minus 1 equal to 0. That is the ellipse equation. Suppose there is a point x1 y1. So you want to check whether the point lies outside the ellipse. Then substitute the point on the ellipse. So x1 square by a square plus y1 square by b square minus 1. Suppose if you get a positive value, then definitely the point lies outside the ellipse. Next case, suppose on the ellipse the point is. So on the ellipse means p and q coincide. So both are equal, right? So x1, x2, y1, y2 all are equal. So if and only if the distance pn, qn both are equal. So pn square may equal to qn square, pn square minus qn square equal to 0. So divided by b square, pn square minus qn square by b square equal to 0. So the value, if you are substituting the point x1, y1 on instead of xy on the ellipse, you will get 0. Then the point x1, y1 lies on that ellipse. Third case, suppose the point lies inside the ellipse. So what about the distance? So q is on the ellipse, p is inside the ellipse. So qn is greater than pn in this case, right? So the case will be like this, right? P is inside, then q is on the line, then qn, the distance, is greater than pn, right? Or pn is less than qn, pn square less than qn square, pn square minus qn square less than 0, pn square minus qn square by b square less than 0. Therefore x1 square by a square plus y1 square by b square minus 1 is a negative value, less than 0. Suppose if you are getting less than 0 when you are substituting the points on that particular relief, then the points are definitely lying inside the ellipse, right? If x1 greater than 0 or x1 less than minus a, so outside that a dash, right? Within the range, suppose we have taken the x1 within the range of a dash, the distance, right? That is minus a to plus a. Suppose if it is outside that range a dash, right? This is minus a, this is plus a. Suppose x1 is greater than the a, small a, and x1 is less than minus a, right? Outer that range, that is x1, mod x1 greater than a. Clearly p x1 y1 lies outside the ellipse, definitely, right? There is no discussion on that, right? Thanks.